a good weekend. Let's see, where are we? We had an update since last time. Let's see, what is today? Today's Wednesday. So Monday was a holiday. Okay, now I know where I'm at. I thought it was Monday again. So, okay, so Monday. So last time we saw each other was Wednesday. On Friday, I did update. Again, it's a snapshot of scores for homework in Canvas. It's not a final. So if you're, I know many of you are still working on 10.5 and 10.1 and maybe even the others. So those will get updated again this Friday, and then they'll get updated again the next. So it's sort of just a continual to let you see where you're at. Yes?
They're also locked, though, so you can't access them.
Anyone else finding them to be locked? Yeah? Okay, I'll take a look once I finish up here because it's not supposed to be happening like that. When I update them, I have to reschedule them. Sometimes I make a change and I forget to do that. Might be it. So hopefully it's as simple as that. But yeah, thanks for letting me know. And again, if you have any questions, go ahead and email me. Even if it's I'm never going to get upset and say, no, just wait till Friday. It's going to no. Because a lot of times you'll tell me something that I didn't intend to happen that's happening, so I can get things reset. So today we've got two more sections. Today we'll do 11.2. Monday we'll do 11.3. 11.3 we're going to pick up some new techniques, some additional techniques, let me put it that way, for taking derivatives when we're multiplying two functions and when we're dividing two functions. So the product and quotient rule, that's Monday. Today we don't pick up anything new as far as calculus is concerned, but it's an application where we can start applying the techniques we've already looked at. So before we get into that, there's a couple things we need to review. What is another word, or how can you think of a derivative? What's another concept of the derivative that we've been using? Slope of a tangent line, right? Remember, slope of a secant line, that is average rate of change. Slope of a tangent line, that is the derivative. That's the instantaneous rate of change. Okay, so those all go together. So let's go ahead and start into 11.2. Pull up the slide deck. There we go. So this is our first application, marginal analysis. So we just said that the derivative is also called, or can be thought of as the slope of the tangent line. We just got a third word for it, the marginal. Marginal is another word for derivative, another word for slope of the tangent line. So when you see the word marginal, we need that first derivative, we need that slope of the tangent line, and what the marginal gives us, because some of you probably have picked this up in your business theory classes, but not necessarily the mathematics behind it. What the marginal is, it's what it would cost or what profit we get, what revenue we get if we sell one more item. How many of you knew that? Okay, a couple of you. Oops. It's not my room, so you're fine. It's water, so it's just water. Get some more humidity. So marginals is one more. So what we're doing is, remember, when we get a derivative, we're getting a slope, which is rise over run. So that slope is telling us that value of the slope is always over 1. So it's telling us what that cost would be for one more item at that point. Okay, so that's what we're doing. Yes? You could get it later. I'm not going to go over there, so no one's going to slip. Yeah, we're fine. It'll probably evaporate by the time we're done, and then the problem's taken care of. Business theory. What's involved in profit? Let's put it this way. So I want to run a business. I want to make a profit. What are the two things I have to consider when I'm trying to make my profit? Expenses, also called costs. And with those, we have two kinds of expenses. We have fixed expenses, we have variable expenses. Good. The other one's revenue. Good. So those are the two other functions we're using. What's the formula to calculate my profit? Revenue. Revenue. Did I get that right? So that's what's going to come into me. So that's a positive cash flow into the company for whatever I sold. And then I subtract off my expenses. I subtract off my costs. So we're going to see that we'll be working in this set of stuff with three functions. And they'll give, one will be the revenue function, one will be the cost function, one will be the profit function. Okay. Sometimes we're just dealing with one at a time depending upon the homework problem. But this is the relationship. Now, I put this out here because sometimes I figure, oh, you're business majors, you must all know this. And sometimes in the past, I haven't talked about it much, and then I'll see on the test, you got everything else right, but you did cost minus revenue. Well, that's backwards, right? You don't want to, cost is not what's coming in, revenue is what's coming, so you got to get it switched. But that switch makes the number negative instead of positive, right? You get the same value, but profit's negative. So just make sure you get that. Again, it's in a sense simple, but it's also very easy to get reversed, especially if you've got stress on yourself because you're taking a test. So just remember, revenue minus cost. And as I work through these, we're going to see the cost function oftentimes is several terms. So you want to remember that this negative sign here, you're subtracting all the costs. You're going to make sure that it distributes through to all the terms of the cost. Because if it doesn't, again, you're not going to get the right answer. You're going to be off and stuff. So that's the little things, but those are the important things, right? So watch those steps. And then the rest is really just much easier. So marginal cost, revenue, and profit. We'll take a look at an example. Sometimes cost is as simple as a linear equation. Y equals mx plus b, where m is the variable costs, right? So if I'm making, what should I make today? Anyone got a good idea of a business idea? What should we make? Sneakers, okay. So we're going to make some sneakers, and the cost to make those sneakers, it takes $400 per sneaker. These are nice sneakers, huh? Yeah. These are just what the cost is. But what else is there? I've got to rent space. I've got to hire, I got to pay some base salaries, whatever. Maybe I've got like a $2,000 fixed cost. So these are fixed costs. And these are variable costs, which include maybe the hours put in by one employee to make that shoe, or the employees that make it up, plus the materials, right? So that's variable costs. So if I've made, let's go here, say I made 10 sneakers, how much is it going to cost me? $4,000 plus $2,000 is $6,000 for my 10 sneakers. What would it cost me to make an 11th sneaker? From this formula. I want to make one more. We made 10. Let's make one more. Total would be 8,000, but what's the cost of just that one? So I've already put this, just 400. Okay, so that's what I want you to focus on, just the cost of one more, because that's what a marginal is. It's 400. It's coming right from that slope, right? It's coming right here. I can say the 11th would just cost me 400. And we would see from this original function, if I took its derivative, right? So if I took the cost of the sneaker derivative function, what would I get? 400x, its derivative is 400, right? X to the 0 power, so that's 400. Derivative of 2,000, it's a constant, so the derivative of a constant is 0, right? So the derivative of the cost function is 400. That's our marginal. So we can see that connection, but I wanted you to see it in an example. Yes, it's 400 because it's a linear equation, but that's because this is linear. The slope is actually the derivative. And so when we get something more complicated, all we have to do is look at what that derivative is, and that's going to give us our marginal cost. Oh, we made 10, but let's make another one for whatever reason. It's going to cost us 400. The thing on these questions that sometimes gets confused, because sometimes in the homework they're going to ask this, how would I calculate the average cost? Let's go back to 10 sneakers. How would I calculate the average cost of those 10 sneakers? Average.
Divide the total cost by 10.
Exactly. So I would take my total cost divided by X, however many. So it was 6,000 that we made, or 6,000 was the cost, divided by 10. It actually costs us $600 per sneaker. If we make more, the average cost should go down, right? Because we're eating up those fixed costs. So if I did with 11, I'd still take, well, I take 6,400 divided by 11. So the variable costs still get in there, but average cost is taking your total and dividing by however you made. And sometimes the homework's going to ask for that, and they'll ask for it with, we'll put C sub A, with a bar over the S. This is average cost, average profit. So this is how many did we make, and we divide. And sometimes you don't know it, but that's what you're really thinking of about as marginal cost. Because in our decision-making process, there's two times we make this decision, right? We have to decide first, when we start making something, how many should we make? And that's when we would go ahead and calculate average cost. Okay, I know my cost for this. How many should I make? I want to get that average cost to be less. So I use average cost there. While I'm making things, that's when I want to think about my marginal. How many more should I make? I've already made this many. Well, it's actually getting cheaper to make it. Sometimes we're going to see that sometimes because of volume of scale and stuff, it actually gets cheaper down the road, and we say, well, why not make one more? Maybe it's free because of the way the formulas work out. Okay, so that's where marginal is how much does it cost to make one more, or maybe two, but we're going to focus on just the one more. Okay, so but you have to tell yourself the difference, that there is this average cost thing. That's not what we're doing when we do marginals. And there's this marginal thing, we're not doing average, right? So those are two different things. Average is sort of the secant line, right? Average rate of change. Marginal is the derivative, the tangent line. So there's those two things that keep coming back to us, and we have to know the difference. Okay. Don't really need to know all this. Cover up over my notes. So here and so these are just the words that basically say everything I did, that we've got a cost function when the marginal cost comes directly from the derivative at a certain value. Marginal cost is derivative. One of the things you'll be asked to do, though, is if you'll be able to find the marginal or the marginal cost for, say, the 11th sneaker. What you want to do is you want to get the derivative and plug in the 10th sneaker. You want to plug in the one before. So in the homework, they'll ask like for the 50,000th and one sneaker. What you plug in is 50,000. Because you get the derivative, you plug in the one before, and then that's going to give you the derivative, which gives you what it would cost to make one more. Okay, so that's just sort of a technical side. We'll go through a few of these. The units are always going to be, right, what are we doing? Cost is dollars. And since we've got a derivative, dollars per unit, right? So that's the units of cost. The thing is, revenue is the same thing. It's dollars made per unit sold when we get to the marginal. Okay? And again, when we're thinking marginal, it's always per one more unit. Profit, dollars made per unit for one additional unit when we talk marginal. Yes, sir?
Would advertising be a fixed cost?
It can be, but it could also be variable because sometimes you get volume discounts, so that, but it could definitely be a fixed cost. And that's You'll have to ask your business professors on that, but I would say it's mostly a variable, but there's some. I used to do real estate. My broker, he had some advertising set up on a regular basis. That was our fixed cost, but then he would also do some special programs. So I think it's both. All right. And so again, this is an important step here, though. When we take the derivative of the cost, we get the approximate cost of one more item. And why is it the approximate cost? Because we're using that tangent line, we're using the slope of the tangent line, so we're following the tangent line. The curve might go down, so the actual cost for making that might be less, or it could be more, but we're following the tangent line, and I've got some graphics that show that. But just notice, when we get the marginal, it is a approximation. And sometimes it's a very good approximation when we get far enough out. You can't tell the difference between the actual cost and the marginal cost, but it is an approximation. There's one example that we'll look at. The marginal cost was $10. The actual cost was $9.99. Close enough, right? But just notice marginal is approximate. I took this out of the text just to emphasize the calculation for the average cost, right? So just it's not the derivative, but they do that little bar over it. It's the total cost at some value divided by however many we made. Okay, so that's an average cost. Sometimes they will ask us to compare those two. And so just remember, this is like a secant line taking from the starting to some endpoint. It's the slope really of the secant line, so it's similar, but it's not the slope of a tangent line when we get out there. Okay, so we may need to compare these two, but they're sort of different things. Could be that the average cost is 600. Well, our last example, at 10, average cost was 600, marginal cost was 400. Okay, so, there's where I got the 400. So we did this. Take its derivative, 400 per item, right? We did this 400x plus 1,000. Doesn't matter what your fixed costs are. When you take its derivative, it's going to become 0, right? So let's look at something a little bit more interesting. It's not a linear equation. So it's a quadratic in this case. So this one's making, what are we making? We're making portable music players. We've got fixed costs of $150,000. Big factory, I guess. What's this 20x? That must be the sort of the variable costs, $20 per each. But then there's this thing, so we're subtracting off a small amount, less than a penny, x squared. So that's kind of like, that must get the volume purchasing then. And so as we buy more, our costs actually go down. So this is a quadratic. And that's a valid thing that happens in business. The more we're making, we get these contracts, and you buy 10,000, I'll give you a break, right? So now we want to find the marginal cost. And now it's not so easy. We can't just look at it. It's $20. Well, it depends on where we're at, because how much are we subtracting off, right? Could be less than $20, especially when we get out to 50,000. Now that discount could make a big difference. In fact, actually, you're going to see it cuts it in about half. So how do we find it? Well, marginal cost, what do we need? We need the derivative. It's nothing new. We've done this, so this is an opportunity to practice the derivative. So what would the derivative be? C of x. What's the derivative of 150,000? 0. Good. And I do this again and again to remind you, because sometimes that's the hardest one. It's a constant, so its derivative is 0. In fact, you may not even write it down, but I always do, just to remind myself that I did take it. What's the derivative of 20x? 20. Okay. You said, yeah, it's obvious. Well, good. It should be obvious, but this is where I see errors. People will write down 20x because they forget that it's to the first power, it becomes 0, the x goes away. It's just 20. What's the derivative of the last term? 2 comes down and multiplies, right? So we're going to get minus 0, 1, 2, 3. 1 times 2 is 2. And then it's x to what power? First power, so we don't write it, but yes, good. 2 minus 1 is, so that's just the derivative. That's what we've been doing. To get the marginal cost at 50,000, or the 50,001, once, I don't know how you say that. What do? We want to find the marginal, we want to find the derivative at 50,000. Okay, because that's going to give us that slope at 50,000. It tells us what that next cost is going to be. So we just take our derivative, which is going to be 20 minus 0.0002 times 50,000. 50,000. 2 times 5 is 10, right? And then we move this decimal 1, 2, 3, 4 places. 1, 2, 3, 4. So it's got to be $10. If you're not sure, you could put in the calculator, but yeah, that's how it is. So the derivative at 50,000 ends up being $10. That's our marginal. And that's in dollars per player. So early on, it's costing us about $20 per player to make it, but as we make more and more, we get out to 50,000, it only costs us $10 to make these now. So that's why you see, the volume of scale. If I can make them and I can make $10, I could still sell them for the $50 I was selling them for. So we're making more profit now with these later ones. We'll see that also. We'll do the same thing. And again, when we get into profit, talking about profit, all we need to know is the revenue, and then we could subtract off the cost. So this one doesn't have it, but what if the question said, and we sell these let's go for $75. We're making quality stuff here. We should make a good markup. We sell them for $75. Is that enough information for us to get the revenue?
And the problem like this is to assume that they're all sold.
Yes. Yeah, why would we make them if we didn't sell them? Yeah. But yeah, we would assume, good question, because that's something they don't usually tell us whether they sold them or not. But yeah, we would assume they're all sold, so what would be our how would we calculate our revenue for 50,000?
You said 75 in the original cost function.
Not in the cost function. Remember, this is going to make up a revenue function. What would our revenue function be?
50,000.
What's that? So 50,000 times 75 would be for that particular one. In general, 75 times X, right? So, for the formula, yeah. So we sold 50,000, we made 50,000, we sold them, 50,000 times 75. So here's the thing, is your revenue function is always going to be whatever you're selling them for times however many you sell. Okay, so that's something you're going to need down the road. And the way they ask the question, they just say, we're selling them for this. They don't tell us that we sold them all, but we assume we sold them all. So our revenue function is going to be this. Okay. And what would our profit function be? Oops. Profit function. 75x, that's our revenue, right? That's positive. That's the cash that comes into us. Minus. And this is not the marginal, this is just, so it's the whole cost function, 150,000 plus 20x minus 0.0001x squared. And notice I put parentheses around that because what's going to happen with this negative sign is got to distribute to each of these three terms. And then I can combine like terms, right? Because I've got a 20x and I've got a 75x. This becomes minus, so you see the 20 gets minus, so it's 55x. So the cost function, and some of you were, I think that's where you were going. You were getting there. you were merging the cost and the revenue functions. But just be careful, when we're talking about profit, we need revenue and cost. But when we talk about revenue, cost doesn't even enter the picture. Profit is not in the picture. It's just the money that's going to come into the cash register or the bank account or something. That's the money in, right? So profit is a combination of the revenue minus the cost. All right? So far, so good? Seem doable? Again, it still has you need the ability to take the derivative. Here's a picture of the same situation. So at 50,000, that's the derivative. Notice when we're doing the marginal, what we're picking up is the slope of the tangent line. The more we make, the less steep that is, the less the marginal is going to be. So the marginal is actually going to decrease the more we sell. So this is a tangent line. But you can see that the tangent line is actually a pretty good estimate for a fairly large number of it, but eventually it's no longer a good representation. If you were doing the tangent line out here, you're way overestimating your costs because they're actually down here. Okay, if these functions continue to hold. So just remember, the marginal is an estimate. We use it for the cost of the next one. Again, it's to make decisions. Should we keep producing some more? Again, good question. Are we selling them? Or do we just have a warehouse full of them? Maybe we don't need them. So there's other things into it. But if we're selling them all, yeah, at this point we should go ahead and keep making it because we've already put the investment to buy the building, to do everything. And now it's only costing us $10 per player. We could even reduce the cost and maybe we'll sell more. So those type of things. Those are the types of decisions you get to make from here. So now we're going to, again, tie all three together. As you see, I kind of like to advance this. So revenue and profit. Again, total revenue is the R function. Total profit is the P function. The marginal is going to come from the derivative of each of these functions. So we take the derivative of the revenue function, we get the marginal revenue, take the derivative of the profit function, we get the marginal profit. Now on some of these, if I know the marginal cost and I know the marginal revenue, can I directly know what the marginal profit would be? We know that profit equals revenue minus cost. So is it true that the marginal profit is equal to the marginal revenue minus the marginal cost? It is. Maybe think back to the derivative rules we looked at, that if you have a sum or difference, yes, you can take them individually. So conceptually it's there. It will work. I suggest when you're doing through the homework, when they ask you to do it, sometimes they'll ask you for the marginal profit. They don't ask you to write down what the actual profit function is, but I would suggest at least writing it down so that, because if they ask about anything about profit, you have to go to that, right? If you want total profit, you have to go to that profit function. Marginal profit only gives us the profit for one more. Okay. Units, again, we talked about this. It's going to be dollars per unit, dollars per 1 unit, or if we're in Europe, euros or pesos or Thai baht, wherever we are in the world, it's going to be those units of currency divided by 1 unit. Marginal is always about 1 unit. And again, you'll see we could replace everything we talked about cost function with revenue or profit. It's for one more. So this is where we get into estimating, and this takes us back to some of the exercises we were doing earlier. We have a graph, and they'll ask us some question: what is the associated marginal cost? The associated marginal cost, is it increasing, decreasing, or increasing then decreasing, decreasing then increasing? So marginal cost is how would we visualize the marginal cost on this graph? What is marginal cost? It's a derivative, and it's a tangent line. So visually, a derivative is a tangent line. So we're going to look at what are the tangent lines doing as we move on this graph. So this is where we have to kind of estimate what a tangent line looks like down here, maybe something like this. About here, the tangent line goes through at one point. I'm just trying to estimate and just kind of go through at one point. Up here, we'd get a tangent line that kind of goes through at one point. So what do you see those tangent lines doing? Increasing. The tangent line. The function's also increasing, but be careful, that's not what the tangent lines themselves are getting steeper. They're getting more positive. Tangent lines are always increasing. Okay, so that's why we had you do some of these earlier, and then they'll bring these back in where they show you a graph. But you have to kind of draw those in, which is hard to do on the computer, right? Although this little tool I've got works on with Chrome, as it was $8 for a year. I'll have to pay again, but it's kind of a nice little tool to have. But then you also need one of these little tablet things. But makes your computer basically do everything. Okay, when x equals 100, the marginal cost is, and then we're comparing to the average cost. So here, before we do this, again, we're thinking marginal cost, but we're comparing to average cost. How does the average cost look on a graph? What is the physical representation of an average cost? It's a linear, it's a line. What kind of line? Beginning to end. It's a secant line from the start to the end. So I'm going to draw in the average cost. So doesn't this feel familiar to what we were doing before? Very abstract. We weren't taught, we have to draw these. There's our average cost. Now we want to compare the marginal at 100. So what do I have to draw here? A tangent line, right? So it's a derivative. It's a tangent line at 100. So again, we've got to kind of eyeball it or estimate it. It's not too bad. And what would you say about those two lines? Relatively speaking, they're about parallel. They're about the same. And that's all they're looking for. If it was less than, it would be going down. If it was greater than, it would be obvious. And you could see at other points that they might choose, it would be different. But we could say that they're approximately equal. Okay. And again, they give you stuff like this, a graph, and they'll ask for different places. But you've got to average is your secant line from start to finish. Marginal is always a tangent line at the place that they're talking about. Cost of 150 items, what is that? That is an amount, right? So we've got 150 items. How do we figure that out? We read it over here. It's a function value, because this graph is a function of cost. It's the cost function. So we go to 150. Our cost is, there's 4,000, there's 5,000, somewhere between 4,000 and 5,000. They give us a choice of 4,400 or $40. I think it's a lot closer to 4,400. So it's got to be one of these. And then now we've got to say the cost, it's approximately 400, and it's increasing at a rate of about 40 per item. Or is it increasing at about $1 per item? How do we calculate the increase per item? What's the thing we're looking for? In the vocabulary we're doing today, that's our marginal cost. That's the derivative. That's the slope of the tangent line. So now we want to sort of draw one of those in here. There's that. And again, I sort of like that. And then I've got to estimate, does that have a slope of 1 or a slope of 40? I'll choose this point that's 125. and that's about 150, so that's a change of 25 this way, and it went up by 1,400. Certainly not 1. It's got to be somewhere around 40. Okay, so you could do the math, but you can see it's not 1, it's got to be 40. Okay, so they'll give you that big differences. So then we can choose, again, taking some kind of an estimate, and again, you could choose different ones, but I would choose maybe 2 points here and here, kind of do a estimating. Yes, it's closer to 40 than to 1, so we'll go with A. Okay, so far so good. Again, see how we're going to an application, but what we're doing is we're tying in the things we've been doing prior to this. So this is a good, I'd say it's a good test review type thing. We get to just look at what we've learned, take some derivatives. We're picking up a little bit of vocabulary, but we're also getting to apply it to one of our major areas of study, right? And here's our last one for today. Find the marginal cost function and use it to estimate how fast the cost is increasing when x equals 60,000. So we've done one similar. Again, how do we get the cost function? Take the derivative. What's the derivative of 80,000? 0. What's the derivative of 340x? 340. The x has gone away because subtract 1 from the exponent, it's x to the 0. So that's that. And then what's this last term? 2 times 5 is 10. So I'll write it like that. X to the first power. So there's our derivative function. To find out how much it would cost us. Yes, sir.
Wouldn't it be 0.3025? Never mind.
Okay. Had me going there because I make mistakes all day long, and I was arguing with them, and because I couldn't see my mistake. What I did is I took 1 times 1 and I got 2. So in my mind I was doing 1 plus 1 is 2, and they were saying, yes, that 2 is not right. And I go, but it's right, because I had convinced, so my mind was in that. It took them a while. I said, oh wait, 1 times 1 is only 1. So we have these, yes.
So can you explain how you get 0 for the 80?
Sure, because it's a constant, so there's no variable there. So if we think of it as a function, it's y equals 800,000. If we graph that as a function, we get a horizontal line at 800,000, right? The slope of a horizontal line is 0. So remember, when we're getting the derivative, we're getting the slope of a tangent line, and a horizontal line, every tangent line is also a horizontal line to it.
So it'll always be 0?
It'll always be 0. So if you've got just a number with no variable, derivative is always 0. Yes. And the same sort of holds true when we have just the one with the x. Another way to think of it, we can think, yeah, it's x to the first, you subtract 1 from it, you get x to the 0, which is 1. But the other way to think of this is 340x as a function is y equals 340x. It's just a line that goes through 0, 0, and has a slope of 340. A slope of 340 everywhere. So every tangent line to this function of y equals 340x will have a slope of 340. So that's why when you take its derivative of a function that's just x to the first power, it's just that number in front. It is the slope. The other ones we kind of go through bring the 2 down, multiply, you get this, and then you subtract 1 from the exponent. Those actually, in a while, they may seem easier and they're less problematic. These ones actually do cause problems because they don't feel quite right. This feels like Little Crow's making it up. He's just doing it. But there are some connections, but you have to think of it in multiple ways. Good question. All right. And so we plug in our 60,000, right? And again, what we're getting is not the cost of 60,000. We're getting the cost of the next one. Actually, this is one that's kind of weird. The costs are going up as we make more, but sometimes that could happen too. Now I don't need that trailing 0, so this is where the 60,000 goes, right? Goes in for the x, and you could calculate that. Let's see. 0.01 moves the decimal 1, 2, let's see, 1, 2, 3, 1, 2, 3. So the cost here is going to be 60 plus the 340. So the marginal cost becomes at the 60,000, and first is its cost is going to be $400. 340 plus $60 per. What are we making here? We are making a PlayStation 4. PlayStation per PlayStation. Okay. Questions? Okay. Let me do this. Let me go into the homework and I'll give an overview because there's a few that I want to point out, like on the revenue ones, so that you can set them up and not get stuck on any of them. And then I've got to fix the issue. Is it only older? Which any past assignments are not working? Okay, that makes it easy. Okay. Uh, 11.2. So go into this. So again, they give us a cost function. They're getting a little funky here, so there's an x in the denominator. Remember, what did we do with that? Bring it up, make it x to the minus 1 power, take its derivative. So this one's a little trickier, but again, similar. Here we have a cost function, a revenue function, and then we want marginal cost, marginal revenue, and marginal profit. Again, they don't ask for the profit function, but I would suggest setting it up first, just so you have it. And then find all values of x for which the marginal profit is 0. So how do we do that? Once we get the marginal profit, how do we find which values make it equal to 0? Take that function, set it equal to 0, solve for x. And in this case, it actually looks like it will be a quadratic function. So you might have to do a little bit of work. You might need a graphing calculator to find those x-intercepts, right? But what we're getting towards is when the profit, net profit, or the marginal profit is 0, maybe I should let you discover that, but what does that mean? Marginal profit is a tangent line. So what does a tangent line with a slope of 0 look like? Horizontal line. Where do you find horizontal tangent lines? There's two places. And you'll see this, where you either have a maximum or you have a minimum in the original function. So the tangent line. Now that doesn't mean that the marginal profit, but in the so this is a preview. We'll see after the test. We get at this part. We start looking at maximums and minimums, and that's exactly what we do. Is we find where the derivative equals 0, and that tells us from the original. So our profit is either maximizing or minimizing. Hopefully, we're at a maximum. I think, yeah, we might be at a minimum profit. If we're at a minimum profit, then we want to keep pushing forward because we'll make more profit if we push forward, right? If we're at a maximum profit, we probably want to shut down the business, close the doors, and because we make more and our profits actually go down. All right. Keep going. Here's some of the graph sort of stuff where you have to figure out what tangent lines look like on it and stuff. So a few of those. Again, another one where they give you the cost, but this is the one to be tricky about. We're told that this is a newspaper. It sells for 90 cents per copy. This is a place where a lot of students get stuck because they didn't give us a revenue function, but what do we know the revenue function is going to be? $99, close. We're doing it in dollars, so if it costs 90 cents, what does 90 cents look like in terms of dollars? 0.9. So be careful with, watch your units on these, because you could do everything else correctly, but if you put in 90 instead of 0.9, your units aren't going to match up. Okay. The other thing is you could convert all of these over here. So yes, this one's going to be 0.9x. That's our revenue cost. So now we can go, because then I can, take that minus the cost and I've got my profit. But this is where a lot of people get stuck. I got stuck there for a while, so I had to think it out. So a couple of these like this, okay? And then they ask you to do a bunch of other stuff. Here's the cost function. Again, here's another one, $1.10 per serving. That's our revenue, so $1.10 times X, that's our revenue function. That's all there is to it. And they get some with, they're giving us a profit function, just a square roots in here. I think you can handle that, getting marginals, getting derivatives, car wash. See, there's, this one. This one threw me for a moment. And it's because I saw, how am I supposed to take this derivative? But then I read it. This is the derivative. So they give us the derivative. This is what we'll do on Monday. We'll look at how to get a derivative of a quotient. But we don't know how to do that yet. So they're actually giving us the derivative already, and they want us to see how the derivative's changing. So we just plug in values to that function. Okay? You don't have to take the derivative. I was going, man, how am I going to teach them how to do the derivative of that thing? We don't. It is the derivative. Okay? So don't spend too much more time of it. It's just you plug in 20 for x, you plug in 60, and you see how it's changing. And that's pretty much the lesson. Okay, so nothing new as far as taking derivatives. Same sort of practice with it. Just noticing the marginal is a tangent line at a point, right? And it's the cost of one more item, or it's the profit of one more item, or it's the revenue of one more item. The average cost is a secant line from beginning to end, and sometimes they'll ask about that, sometimes they won't, but they're two different things. Sound good? All right. I'll get the homework fixed. If you've got questions, stick around and we'll work with you. Thank you.